This is a gravitational wave spectrogram. In fact, it's the spectrogram for the very first gravitational wave ever discovered, GW 150914. The x-axis shows the passage of time and the y-axis shows the frequency. The colour of the spectrogram indicates how strong that frequency is. So what this means is that as the gravitational wave happens, you get a chirp. It rises in frequency, going yip. You can download and 3D print a model of this gravitational wave spectrogram. But I thought when it was printed as a single colour, it didn't look very good. It didn't look terribly interesting. I wanted to try and print it in the blue to yellow colour gradient that was used in the actual gravitational waves research paper. The problem is I only have a single colour printer. I looked around online for graded filament but couldn't find any that went from blue to yellow or from one colour to another over the length of filament that I wanted it to. So knowing that other people had succeeded in 3D printing their own filament, which they ran back through their 3D printer, I decided to try and extend this by printing my own colour transition, colour graded 3D printer filament. To do this, I had to design my own filament in Fusion 360 and then get it to print two colours on top of each other on my 3D printer. Okay, so I've opened up Fusion 360 and the first thing I'm going to do is just create a sketch to provide some boundaries and reference lines for the coil I'm going to create. So because I've got a Prusa, the largest diameter I can print is about 200 millimeters, so I'm going to set a 200 millimeter outer circle. And I'm going to set a roughly 80 millimeter inner circle because that's about how tight you can print this coil without it getting jammed in the extruder and things like that. You could probably get a bit smaller, but I've found this to work quite well. So I'm going to finish that sketch. The main thing I want to do is come up to create and create a coil. Now this is actually designed for creating springs, but you can use it to create a spiral spring. So I've set the center of the coil and I'm setting the inner diameter of this spring coil to 80 millimeters. And you can see there it's created this spiral coil. So if it creates a normal spring, you just go in here to type and click spiral. It's already on spiral because that's what I used previously. The section you can change from circular to square to triangle. I've got it set as square because that'll be a useful surface off which to build my hexagonal coil later on. I'm going to set the section size to 1.75 millimeters. I'm going to set the pitch between, so this is the spacing between coils, to 3.5 millimeters. And then if I set 17 revolutions, so 17 total passes around the coil, that brings me out to my 200 millimeter mark. So that's looking pretty good. So I'm going to go OK and construct this coil. So now I have a coil with a square section. And I'm just going to go and switch off my reference sketch just to get it out of the way. I don't need that anymore. What I'm going to do now is I'm going to create a sketch on this top surface of the coil. So select the top surface, hit sketch, hit this outer edge, and then select offset. And I'm going to create an offset of 0.875 millimeters, which is half the diameter of the filament that goes through the printer, and this is going to be a useful path and reference line that I'm going to sweep things along and use as a guide later on in this process. I need to zoom in here and cut off this little bit of excess that's sticking out in front. Oops. Wrong bit. Cut off this bit, please. There we go. And now I'm going to finish that sketch. So the next step, I'm going to come up to construct and pick plane tangent to face at point, And so I'm going to construct a plane tangent to this face at this point and go OK. And now I can switch off this square spiral because I don't need it anymore. It served its purpose. So now I'm going to create a sketch on this plane, and I'm going to just rotate this so I can see it a bit more easily. And I'm going to create a polygon, in this case a hexagon. So I want an inscribed polygon because I will set the maximum point-to-point diameter of this polygon to be 1.75 millimeters, the diameter of the filament. So select that, select my center point, drag it out, and set the radius to 0.875 millimeters, so the diameter is 1.75. And the good thing is it defaults to hexagon. If you need a different profile shape, you just up the number of sides. I found hexagon to work quite well in trying to approximate a piece of round filament. And I'm done with that sketch, so I just hit Finish Sketch. So now I have my hexagonal profile, and the path I want to extrude it along. So to create my filament coil, I'm going to go Sweep. I'm going to sweep this hexagonal profile along this spiral path. Hit OK. And we're done. Now, if you want to do something like Das Meers to color filament or the multi-material filament that CNC Kitchen did, all you have to do now is export this and slice it. But to create my graded filament, I want to cut this from one end to the other so that it's full thickness at one end, tapering down along the spiral to a thin section at the other. And then I want to flip that and so have it taper the other way in order to get the other color of filament. So to do this, I'm going to use a loft, and to start this loft I am going to create a couple of sketches. So I'm going to create a sketch on this hexagonal face in the center. Just rotate it up a bit so I can see it easily. I'm going to just draw a square, and I want it in line with the top edge here, and in line with the bottom edge here, and wider than the profile section. So that's one sketch. Now to do the other sketch, I want to do it at this end of the filament, and I'm just going to switch back on my inner path there. I'm going to construct a new plane, so I'm going to construct a plane along path. This is my path, and the plane has actually wound up at a pretty good spot, so I'll just leave it there. Zoom out a bit, make this smaller. This plane doesn't need to be that big and in the way. Now the reason I've done this is so I have this section of filament left that doesn't get cut at all, and that will help some slicers like Prusa Slicer with working out that this thing is actually on the bed, rather than tapering it all the way to a thin section at this end. So at this end, what I want to do is create a sketch on this plane. So select the plane, create sketch, and I'm going to create a polygon at first, which will give me some reference lines to work with. So I'll hit that center point, bring my polygon out, and again put it to 0.875 millimeters. And the reason I've done this is I just want this bottom edge as a useful reference. So I'm going to create a square, a rectangle, get it in line with that bottom edge, and slightly wider than the profile, the diameter of this profile. And I'm going to set the thickness of this to 0.2 millimeters. The reason I'm doing that is because I've found 0.2 millimeters to be a good first layer height for this. If you want to try 0.1 millimeters, you can, it should work, or even thinner at 0.05 millimeters, but 0.2 millimeters should work on most printers. To finish this off, I'm just going to cut away some bits I don't need and finish that sketch. Now, the sort of final step in creating this is to loft this spiral all the way from one end to the other. Now the problem is my computer can't handle both screen recording and lofting at the same time. So I'll just have to explain this and then show you the end result. So what I'm going to do is try to loft it, and I need to select two profiles. So the first profile I'll select will be this full square here, make sure it's all selected, and then at this end the second profile will be this thin rectangle. Then once I've done that, I'm going to come to Guide Type and click Centerline Guide. And then for my center line, I will select that spiral that I created earlier, that center spiral. And once you've done that, you will either go cut or intersect. So you can do this twice. If you go cut, you will get 1/2 of your filament, and then you can export that as an STL. And then you can go intersect, and you'll get the reverse of that. You'll get the other half of the filament, which you then export as a separate STL, and now you've got your two different tapered filaments which you can export into your slicer. So I'm going to stop the screen recording for now and let this thing crunch the numbers. I shall return once it has done that.
A few moments later.
Okay, welcome back. So once you've completed that loft, this is what you get. So this is the inner edge of the coil, and it starts thin, and as we work our way out, it gets thicker and thicker and thicker and thicker out to the far end there. And this little plate I've added in order to give that end of the coil more surface area to stick down to the bed. This will help it print properly, stop it lifting, which can be a problem. So they're easy enough to add. If you've got this far in Fusion 360, I'm sure you know how to do a quick sketch and extrude. So this is just a 0.2 millimeter thick plate to stick it down to the bed. So that's 1/2 of my coil, and this is the half that I will print second. So this is the upper surface that you see there and the outer edge. So I will print this second, and then when I actually use this as a coil to print my object, this is going to be the first color that prints. So for the LIGO spectrogram I want to print, I want it to be blue at the bottom and yellow at the top. So this bit that I print second is going to be blue. Over here, this is the opposite side. So when you do that loft, instead of clicking cut, you click intersect. This is what you get. You get it thick at this end, tapering out to thin at the other. And again, I've added this small 0.2 millimeter thick plate so that it can stick down to the bed more easily. And as you can see, out at this end, it's tapered down to a 0.2 millimeter thick wedge. So this is going to be the bottom section of the coil and the bit I print first, and when I create the coil, and then when I print the LIGO spectrogram, it will be the last color. So this needs to be yellow. And when I import both and color them, you can see sort of how this is going to wind up. This is going to be yellow. Now, because this is getting super thin, the slicer will not actually make this bit yellow, and this is likely to be fully yellow for some distance, some number of centimeters. When it gets out to about 0.1 millimeters in thickness, then the slicer will actually put in some blue. And as you can see, it goes blue all the way to the other end. And if I flip it over, You can see mostly yellow on the bottom, tapering to blue. So now you just export those two coils as STLs and slice them in Prusa Slicer, or anything else you want to slice them in. Okay, so now we're in Prusa Slicer. I've got both models imported. Now, because of the way Prusa Slicer drops and centers a model, you will have to move the X and Y coordinates of the second model to make sure it's lined up with the first. And that's reasonably easy to do, because when they're different colors, you can pretty easily see when they're concentric and when they're not. Now I'm going to print this with a 0.1 millimeter layer height resolution, which means my color mix will change every 0.1 millimeters. So in printer settings, I've got it 0.1 millimeter layer height, but my first layer is 0.2 millimeters, just to make it stick down to the bed more easily. I've added some extra vertical shells and horizontal shells just to make sure it's solid all the way through. Infill we don't need to worry about because it's going to be solid. Loops, I've turned skirt and brim off because we don't want a skirt or brim, because we're already at the maximum diameter that the Prusa can handle, and it does a purge anyway before it starts printing the model, so we don't need that. Don't need any support material. Filament settings, I've just got standard PLA settings. I like to print nice and hot in my PLA, so 215 for the actual extruder, and then 65 on the bed to give it the extra heat to keep it down. And then no changes in printer settings. So then we're ready to slice. So what I do is I hide one coil and slice it. So I can slice this. I won't bother doing it now because it'll just slice, export that, and then I unhide that coil, hide the other one, and slice and export the G-code for that. So now I've got two separate G-code files. Oh yes, one thing I did forget, you do need to go into printer settings. Under extruder, you go down to lift Z, and I've told it to lift Z 2 millimeters. Every time this moves, it will lift Z 2 millimeters before moving, and that will stop it crashing into the previously printed part of the model. So we're going to print one part first, and then print another part over the top of it. So that means we need to clear the part as it travels so that we don't bash it off the bed with the extruder nozzle. Having done that, you then slice each of these things separately and export. Now, having done that, if you have a simple printer like a Prusa Mark 1, you can just run the two, you can level your bed and run the two files separately. The problem with more modern printers like the Prusa Mark 3 is that it does the automatic bed leveling routine. Now I tried to shut the automatic bed leveling routine off, but then I couldn't get the Z height quite right. It was a real pain in the neck. And what it turned out to be far easier to do is to open both sliced G-codes for the two pieces of filament in one in text editor and splice them together manually. So what I've got here is my first part of the coil, so the inner part which prints on the bed first. Its G-code ends here, and I have added a note of a splice here, so I am splicing in G-code that, and all I've done is I've gone to, mostly what I've done is gone to the other G-code file and just copied and pasted the G-code. So I've added this before layer change to tell the printer that there's a layer change here. I've then added an M600 to tell the printer that I want to change out the filament. So it does this layer change and then gets ready to change the filament. And then everything from here on is just the second G-code file copied and pasted in. And if I go all the way to the bottom, ignore the Prusa metadata, you can see where the splice ends, so that's the end of the second G-code file, and then I just have the standard Prusa G-code for shutting down the printer, cooling down, things like that. So now I just load this onto my printer as one file, and when it finishes the first part of the filament, it will throw an M600, move off to the side, beep at me, tell me to change out the filament. I can change out the filament and then print the second part of the filament. So let's do that. And this is how it came out. I'm really pleased with this. I think it transitions through blue, green and onto yellow very, very well. I'm surprised with how well it turned out. Now, because this has a hexagonal cross-section and is actually smaller than the original filament used to print it, I need to run this through the printer at about 150% flow rate in order to get a good print. But all I had to do was slice the gravitational wave spectrogram as though it was one model made with one colour, and then just use this filament to print it. And this is how it came out. I'm really pleased. For a first go, I'm really pleased with how this came out. I think it compares really well to the actual gravitational wave spectrogram image printed in the paper. Okay, I could do with a little less yellow here at the high frequencies, but overall I'm very pleased, and that was achieved with a single nozzle, single colour 3D printer.